Awesome. Dr. Jennifer Prendki, welcome to the show.
Thank you. Thank you for having me today.
Of course, of course. So, just to kick things off, do you mind walking through your background and all the way up to what you do today?
Yeah, absolutely. So, this is I have kind of a unusual background, even though it's not too unusual for data scientists. So, I'm originally a particle physicist. And I actually, so I was, this is something I always wanted to do. And so I'm a experimental particle physicist, which means I used to work on doing data analysis on the data that's collected from large particle detectors. And so my story was I jumped into data science and machine learning when basically I graduated with my PhD at the end of the recession, the Great Recession. And so I gave it a try with a postdoc for a year, and the project I was really passionate about didn't get funded, or at least not to the extent that I was hoping for. So I went into thinking I really enjoy data analytics and data at scale. And so I realized there was an entire industry or an entire space within the industry focused on making sense of data for ad tech companies, for social media, for e-commerce and whatnot. So this is basically how I made the jump. And so I was lucky enough to get a job in Silicon Valley, and then I grew my career. And so soon enough, I got my first jobs for as a manager, right? So at that point, I realized, my job is getting very hard because now I have to deal with a large number of data scientists coming at me and complaining that they don't have enough servers and they don't have, the means to prepare the data they're going to work with. And so, all things in one, the first few months of my first managerial job was about going to the CTO, begging for more resources and better computers. And I realized I was not going to make it that easily because you can have the cost argument once, but you cannot go every month, ask for 50% more money for processing the data, right? So I fell in love with this problem of trying to understand whether you truly need as much data as everybody thinks, right? And so I started doing my own research on ways to basically do machine learning cost efficiently by reducing the amount of data first. And so I was pretty successful. I discovered the concept known active learning. So active learning is basically it's like supervised learning, but you try to go step by step instead of throwing all of the data at once. And that worked pretty well for us. And so eventually after a couple of jobs in large companies and a startup that was focused on data preparation called Figure 8, I decided to start my own company to focus on that problem because, as we all know today, the consensus is that the more data, the better. And I sort of wanted to challenge that belief and bring solutions for smaller companies to be able to achieve profitability in machine learning.
Amazing. Wow, what an impressive background. And, particle physics to machine learning and artificial intelligence. Is there a lot of overlap there?
In terms of skill set, it's extremely, extremely high. So basically, think of a particle accelerator as the one way where you can collect massive amounts of data. In fact, the size of the data set I was dealing with as a researcher were comparable to what you see in the industry today, even though I did my PhD basically 12 years ago, right? So it's it does have a lot of overlap. A lot of the tools are not exactly the same ones, but obviously you're going to use statistics, you're going to use, the same math or whatever. To some extent, I'm going to say as a particle physicist, you do have to understand the math that typically you would need to understand if you truly want to understand how a machine learning model actually works. So.
I see. And this whole idea that more data isn't always better, and a lot of times it's more about the quality of your data rather than the quantity of your data. I think Andrew Ng had used the term data engineering at one point, and I know you've coined a term as well. I think data prep ops is, if I'm not mistaken.
I can draw some light on these different concepts, right? So first and foremost is you're absolutely right. Data quality is important, right? And so I think about 4 to 5 years ago, there was a real realization on the market that, okay, the quantity of data matters, but if my records are corrupted, it's not going to help my model. So I think a lot of companies did a good job of promoting data quality, specialized in data quality. I think we want to take the concept to the next level where it's not just about data quality, it's also about data value, right? And so the difference here is like, think, just a simple example is like, if I'm building a facial recognition model, somebody sends me a picture of Mount Everest, it can be the highest resolution ever and hence be very high quality, but it will have no value to what I'm trying to achieve, right? I mean, so, and so what's kind of challenging in like understanding value or assessing value is that you need to understand the context where that data is going to be used, right? I mean, which brings up to like not looking at the data outside of like a better understanding of what's going on, right? So, Andrew actually like brought up like, and so this is like a very recent term like coined as data-centric AI. What data-centric AI actually is like the belief that in order to make your models better, you should spend more time or you should focus on trying to tune your data and improve your data as opposed to improve your models. So the reason that why that makes sense is like we've spent a lot of time over the last decades on like understanding like how to build models the right way, tune the models the right way, how to do hyperparameter tuning and choose the right architectures. But people still see like basically data preparation as something that needs to be done manually, right? And so a lot of experts actually agree that by spending the same amount of time on your data as you would on your model, you would basically see like a significantly better, like improvements within your model. So why not do that, right? And so it's interesting because like Andrew like basically coined the term for data-centric AI about like a year and a half ago, and it's grown in popularity. When I actually started Alectio like 3 years and a half ago with basically like this mission in mind. So I'm glad to see that there is like a real awareness on the concept, right? So talking about data prep ops like takes the idea of data-centric AI to the next level, which is basically like a data-centric AI is essentially the belief that you should allow yourself to touch and improve the data instead of using that as a static object when you build a model, right? And basically what data prep ops is like the operationalization of data-centric AI, right? I mean, so it's a little bit like what ML ops is to model-centric machine learning, data prep ops is to data-centric AI. So it's like a series of tools and basically like processes where you're gonna be able to like improve your data over time. People usually think about data labeling because like you can improve your labels as you go, but there are actually countless number of things you can do to your data to try to make it more like better and more suitable to your model. Like curation of the data is one. You can think of like applying data augmentations, generating the right synthetic data, collecting the right data instead of collecting data randomly and then narrowing down afterwards. You can even think of like a way of doing data-centric AI would be to identify records that are harmful to a model and try to take them off. So lots of like interesting things going on in the space right now.
Incredible. Yeah. So that's really interesting. I mean, there's a lot that can be done to make the data that's being fed into a machine learning model better. And just to sort of reiterate what you had just explained, there's the concept of data-centric AI, which is more about sort of tuning your data, just like you would tune like hyperparameters in a machine learning model. But data prep ops is the operationalization of that. So how exactly do you build an application, for example, that lets you tune your data and understand how high quality your data is and how you can improve the quality of your data? Now, I frankly don't know a ton about what that looks like, but it seems to me like a big part of that is having domain expertise, and it may not be as like formulaic as maybe just analyzing a dashboard and digging through data. But part of me thinks that maybe it's about understanding like the context in which a particular model may be applied and understanding, what features are relevant, what features are not relevant. I'm curious, like what does this actually look like in practice, like from a more conceptual level to a more practical level, like in an application like Alectio, which of course to the audience or anybody who doesn't know, Jennifer is the founder of.
Okay. All right, perfect. So basically, like first and foremost, right? I mean, so this is true of all machine learning ops operations and tools you're gonna have. It's like what you're trying to do is like provide engineering solutions for an iterative process, right? Because regardless of whether you're doing data-centric AI or like model, like centric AI, what you're doing is like you're tuning your model, which means you're iterating, right? And so basically like that goes with like things where you need to keep track of like the changes that you made when you hyperparameter tune. You want to make sure that you don't try the same set of hyperparameters multiple times when you make changes and so forth and so on, right? I mean, so basically like maintainability, like reproducibility of the experiments are going to be things that you need to take care of when you do traditional ML ops, right? Now, if you touch the data, same thing applies, right? I mean, so it's like now you're in a situation where as you build up your data set, you're going to make some changes, you're going to see what happens. And then you're going to say, I need to add more data, remove data, find problematic labels, modify them, and so forth and so on, right? I mean, so the basic things apply as well, where you're going to need versioning, you're going to need a way to store like the data that was used. Think of like a situation where you're curating the data, you need to keep track of like, I tried this didn't work. So you need versioning of a data set. You need the traceability of what was already tried, right? I mean, so, for example, like the Alectio platform has a label versioning system, because like when you're going to fix your annotations, you're going to make changes, you're going to have several copies of the labels for the same record, right? And so you need to keep track of like, what were the changes that were made, right? I mean, so when it comes to data labeling, you're going to have like, like labeling instructions you're going to send to the labeling company that are going to generate the labels for you and so forth and so on, right? I mean, so it's a lot about, the workflow first and foremost, right? I mean, so it's like the difference with like regular ML ops is like instead of like modifying the model, you're going to modify the data set, right? And then you're going to keep, like create feedback loops and so forth and so on. So a lot of the tools are similar, but whatever, like, things or issues you see with like, keeping track of the model, you need to apply the same things to the data, right? The other part, so the way that we function, we're very focused at first on narrowing down the data that matters, right? I mean, so the original premise of Alectio was you collected 10 million pictures. There is no way that every single one of these 10 million pictures are gonna matter equally, right? And the idea is like the information is not equally distributed everywhere. So you want to find like the places in your data where the information is there, hopefully in a way that a subset of the data actually covers the same amount of information than the entire data set, right? And so in order to do this, right, I mean, so we have our selection engine. Of course, it's complicated to explain like how exactly this works, but tries to like build up or like identify dynamically which data is likely to be helpful. But then we're talking about selecting raw data. So you need to annotate that data, right? I mean, so basically you have a workflow where it's like, I found 500 records, which I guarantee are very likely to help your model, right? Now we're going to send that to a labeling company, right? So this is where the expertise enters, right? I mean, so it's like, who should do the annotations? How quickly they do this? Like there's also the cost optimization side of things, which is like, you can always send that to the most expensive labeling company and trust that they're going to do a good job. But maybe you don't need that level of performance. Maybe you can do well with less than this. Maybe you need something that's extremely specialized, and you need, like, if you're doing medical imaging, you're going to need doctors to take care of this annotation. So basically, like, the way we resolve this is, we build an entire marketplace of labeling companies where, we do some sort of like a resource allocation, like system for data labeling, right? And so that helps pair the right company and the right problem with the right labeling company based on their availability and so forth and so on. You can imagine a situation where the labeling process is automated. If your use case allows you for you to do that, it can be like a pre-trained model. It can be a weak supervision kind of problem if somebody is interested in looking up what that is, right? And then when you get that, it needs to go back into the system. Your model needs to know which labels it needs to rely on or whatnot. Like there is you can also induce like a feedback loop over there where it's going to be like, okay, I got those 500 records annotated by a company I was recommended, but how do I make sure that these are the correct labels? Is there a way to automatically audit? So there are many different ways of doing this. We do that with anomaly detection to try to identify like what is likely to be an outlier. It doesn't mean it's wrong. It means like, you may want to invest a little bit more time making sure that this is right, because this is going to be data that's critical to your process, right? And so the entire orchestration, like, for example, like one of the challenges for us is like, you're taking somebody's data and sharing that data with a third-party labeling company who's going to annotate the data, which means you have an entire privacy layer, which, like basically you need to make sure that they only have access to the data that they're supposed to have access to for a certain period of time. When they send back the results, like permission needs to be revoked, right? And basically everything needs to be traceable for compliance issues, security, data security issues and whatnot, right? I mean, so it can take many forms, but it's like whatever tools we ever created for ML ops, going from like a model versioning, traceability, reproducibility, deciding when it's time to retrain the model and whatnot, needs to be applied, but on a data set, which comes with additional challenges, because now you're talking about like for example, our label versioning system is like it's record level, because of course you don't need to reannotate every single record every single time.
Interesting. And so there's a lot of different players in this ecosystem, it feels like, that participate in the entire data labeling process. And I'm curious, like, what does it look like in terms of like integrations? For example, data catalogs. A lot of organizations nowadays have data catalogs to manage their repository of data and have an understanding of what features they're able to collect, and maybe even the health of particular features.
Yeah.
And then you have like the labeling teams, the folks that you're sending the data to, that'll label the data. And what is the integrations for a tool that's in the data prep ops space look like?
Yeah. No, so for like generally speaking, like data prep ops has different flavors, right? I mean, so basically like I think what makes us unique and what we've done really well is basically like pretty much what you say, like the ability of like the workflow, right? I mean, so basically like taking, on the one hand, like the way we proceed is like a user has an existing model, a raw data set or a raw data stream. It can also be like a data that continuously keeps coming in. It can be a synthetic data generation process, right? And on the other end, basically what we're trying to do is like guarantee that their model gets trained with the best data possible, right? I mean, which involves the best subset, but the best labels, the best augmentations being applied to that data set and whatnot, right? Of course, there are some parts of it where you have all the tools that do a really good job, right? I mean, for example, a company like Trifactor is going to do really well on helping you identify like the features that you should be using. Like you have some other tools and processes you can use to like identify missing data. Typically, we focus more on like taking like basically like reducing a data set and in size and not so much on selecting the columns or selecting the features, because as you said, basically you can integrate the sort of tools and basically take whatever data like makes sense as an input. And basically our goal is to manage and coordinate, orchestrate everything, right? It doesn't mean that we know how to do everything, right? I mean, so basically like you can imagine that, on the labeling side of things, like once we identify like here is the 5% of the data that really matters, you can still plug and play whatever annotation tool makes sense for your use case. We have situations where the customer is doing something very specific where they have the experts in-house to take care of that annotation layer and whatnot, right? And you're absolutely right in the sense that the future is going to be like plug and play together eventually in such a way that you actually have like traditional ML ops companies, right? I mean, like Data Robot or like H2O or whatever, where they help you build the right model, but they don't give you tools to like decide like really like which data should be used, what you should collect or whatnot. And then on the other side, ML or data prep ops company, because when you plug those together, you really have an end-to-end where what ML ops companies technically do is like build the best model possible for a specific data set, when data-centric AI in general and data prep ops companies are trying to like build the best data set possible to go with a specific model, right? And so once you combine both together, you really have this never-ending cycle of like optimizing both at the same time.
Awesome. And, in an ideal world, an ML company would have a high quantity of data, but they would also have high quality data. Do you think one's more important than the other?
So it's like, look, we've done a lot of research on that topic, right? I mean, so basically, like the answer is like it depends on the use case, right? I mean, so basically, like there is it's essentially a trade-off, right? I mean, generally speaking. So we actually did research on like basically like how much worse can you allow the data to be until, like basically like the question is like, is it better to have 10,000 records that are annotated perfectly and really high quality versus, like a data set of 50,000 records where only 95% or 90% of the data is annotated properly. And so, it's interesting because you have some models that are extremely sensitive to whatever is wrong. And so you would have like a handful of harmful records and it's going to take your model off completely, right? I mean, and so, when you're dealing with that type of model, which are extremely unstable, you're probably better off having like a high quality data set, even that is smaller, right? When other situations you can have the opposite, right? The other kind of interesting situation over there is like it's also a cost kind of trade-off situation over there, right? I mean, because normally when you annotate data, right, what happens is that in order to ensure high quality, you don't generate like the labels just once, right? I mean, so imagine you're doing autonomous driving, you're working with images. What labeling companies usually advise you to do is like to have that data re-annotated 3 times or 5 times by 5 different people. And then you take the average, right? And so once you take the average, you can assume that basically if there was an outlier, it should be gone, right? I mean, and so that avoids any bad players or like accidental mistakes or whatever. But now if you do this, it's like you're annotating the same data set 5 times, right? I mean, so basically like you have a huge trade-off in order to get the right quality in terms of cost, right? I mean, so, and then if you choose to annotate or re-annotate only 3 times per record, right? Obviously it's going to be cheaper, but obviously, like if there are mistakes, you're more likely not to catch them if you do this and whatnot, right? I mean, so, and, so a company that has a lot of money and a lot of data can afford to annotate the entire data set 5 times, even though with the looming recession, I don't think it's necessarily a good idea to agreeing to do this anyways. But, it's like, I think it's high time that the industry, starts focusing, on the trade-offs, from a financial standpoint, because otherwise you can have, magnificent models, magnificent applications that don't bring money to the organizations that build them.
Makes sense. That makes sense. In terms of just general telemetry to help gauge the quality of a particular data set, and also like the quantity in terms of is there enough data here? What are like some normal measures to evaluate and make decisions on, okay, like this data is good enough, or this data is we have enough of this data?
Yeah. No, look, again, depends on the type of data. Depends, basically, some people would say, as long as, I don't have missing records, the formatting is correct, I have, consistent, information across my data set or whatnot, this is good enough. Some people are gonna take it one step further, which is basically, I don't want redundancy, right? I mean, so basically, and then making sure that every record is gonna bring, novel information, right? There is no consensus on the right way to measure quality, because it really truly depends on the type of data and what you're trying to achieve with it. So the take that we're taking, with our approach is we're trying to select data based on how it impacts the model, if you will, right? I mean, so basically the idea is that for me, the best measurement is basically look, if a subset of data truly helps and you can actually prove and you can measure that there is a true differentiation and there is a boost in the performance of the model at training time, you can assume that this is good data. This is not only high quality data, but it's useful data, right? And it's valuable data that's going to help the model, right? And so for me, this is the strongest measure. It's let the model decide for itself if the quality and the value is high enough that the data should be used. And that's really one of the, basically our selection engine within the Alectio platform is trying to do.
Got it. Very, very helpful. And I just want to sort of switch gears and talk a little bit more about the benefits of having maybe a smaller quantity of data, but higher quality of data. And I know you've written about this at length as well, and it's part of the work that you do is shedding light on the environmental impact of having higher quality data and less data to train models. Can you talk about that a little bit more? How does the quality of data have pretty direct environmental benefits?
Yeah. No, look, like it all goes down to like basically the more data you have, the more space you need to basically put this. And so at some point, like the only option you're gonna have is like dump everything on like a huge database, a huge like S3 bucket somewhere, right? And basically like this is gonna, like obviously like mean like additional energy for a data center somewhere, right? I mean, so we're way beyond past the times where you could put all of your data on a CD-ROM or on a USB key, right? And then basically like now it's like, and it's not gonna get any better, right? And, I mean, so basically like the issue we're having is like, actually something that's interesting to point out is that a lot of the data centers nowadays are not built in cold places, and a massive amount of the energy used to run those data centers are actually going into cooling of the systems, right? I mean, so in other terms, like it would be like more environmentally friendly to have like data centers in cooler places like Alaska, as opposed to having them in California, in Texas, in Florida, or wherever, like South Belt state, like we usually put them, right? So, but anyways, right? I mean, so it's like, so that's one aspect, right? I mean, the more data you collect, the more data you need to store. And so basically like you need to put that eventually in a data center somewhere. The other side of this as well is like the more data you have, the more you're gonna need like computational resources to train your model with it, right? I mean, so, obviously like there's like a cost, situation or impact over there, because like, it means like you're gonna have like more data means like larger EC2 instances, longer training times, and so higher cost if you're using like a cloud company, right, to host your training process. But same thing, it's like it consumes electricity, right? Unfortunately, like very few of those, like cloud resource providers actually use clean energy. There is commitment from Google and Amazon to go clean, but that was traditionally not the case up to now, right? I mean, so it's something that people don't necessarily think about when they do machine learning, but we're actually pretty wasteful, right? I mean, so it's interesting to note this. So, yeah. And so one thing that I usually like to point out as well is basically when you look at industries in general, right? The most polluting industries like agriculture, like, the clothing industry, the fashion industry, right? I mean, smart cities and whatnot, right? Or cities in general. Everybody's trying to reduce their carbon footprint, right? I mean, so it's like, they have higher carbon footprints, but it's trending down, right? When we're on the opposite end of the spectrum, where to some extent you could say like the amount of like carbon dioxide that's generated by the big data industry is not that large. It would be something of the order of like 2 to 3%, but it's going up and it doesn't show signs of stopping, right? And so I think more awareness needs to be drawn to that problem.
Yeah, I mean, that's incredibly important. I've read a few articles here and there just highlighting the amount of energy that some of these models consume, some of these larger models that are pretty popular, and it's mind-boggling. It's like you wouldn't necessarily expect there to be such a large carbon footprint from these AI companies, and even some of these blockchain mining companies as well. But it's absolutely mind-boggling, and it's good to be able to sort of focus on that earlier rather than later, like you said, since the trend is only getting worse right now. And in terms of the economic impact that this has within organizations, so organizations that may want to focus on their data quality, does it give them any sort of leg up when it comes to like the impending recession?
That's so it's very interesting because like, so I literally, like, the mission of the company when I started was like, so I was trying to solve the same problem I had faced as, like a head of machine learning, right? And namely, like, not being able to, allow my data scientists to basically like train the entire models, like with the entire data set or whatnot. And so, basically, like I wanted to be able to achieve the same with less, right? I mean, so, and so it struck me as a huge problem in the sense that as it becomes easier to store data, like obviously like people are trying to store whatever they can, and then you're starting to have this sort of discrepancy on the market where if you're an Amazon, you're a Netflix, you're a Google, right? I mean, basically like you're gonna collect a lot of data and you can afford to do that and you can afford to build models with this. And so those are the same companies that are promoting the big data movement, right? I mean, so I actually call that the big data lobby, right? On the other end of the spectrum, right? I mean, you have the smaller companies that struggle more with putting the right place, processes in place to collect data. They might not afford to keep everything. They might not afford to keep the data for too long, right? As we keep going, like you really have like this huge discrepancy coming up, right? Where smaller companies have less and less of a shot to make it in AI compared to larger companies, right? I mean, so the mission of like everything that we do was really like to democratize AI by making AI more affordable. And I know what better way to do that than reducing the amount of data, right? I mean, so if tomorrow like somebody can, look, we know we're able to do this, but there's still a huge like perception on the market that you need as much data as possible, right? And I really want to see this shift between like big data and big information. That's the way I call this, right? I mean, so basically like, really enable smaller companies to, trust themselves, believe that they can do AI even with smaller data sets and reach like very good results regardless.
I see. And that's sort of thinking of this data quality push as being almost an equalizer in the AI space.
Exactly.
Obviously there's economies of scale that exist currently with these large companies, and so that's really, really interesting. I want to talk a little bit more about Alectio, and I hope I've been pronouncing it right. It's Alectio, right?
Perfectly right.
Okay. Yeah, just wondering. So in regards to Alectio, what is it that you're most proud of that the company has worked on, built, done since inception, and what are you most excited about moving forward?
Yeah. No, so look, like I'm proud about everything we've done because we've achieved something which is really unique, which was like, remember, like we started the company like 3.5 years ago. There was no talk of, like data-centric AI. That wasn't something popular. In fact, when I was pitching investors back in the days, it's like, what is this? And, like big data is the future, right? I mean, so it's like, not only that, but the technology necessary to truly understand how and what data impacts a machine learning model literally did not exist, right? I mean, so basically like everything, all the underlying technology are, discoveries we made ourselves, algorithms that we wrote, and it's not something that you could find a paper for, and it's not something that you could find, like an open source library to just integrate in your process, right? I mean, so I think we've achieved like a magnificent, progress or whatever. One of the things, so we started the company with this concept of active learning, which is like, see this as incrementally growing a data set. And even though this existed back then, like the way that you would grow the data set was really brute force and arbitrary, right? And we replaced that by a machine learning model. So we literally open up the way to additional research in this space, right? And what I'm most excited about right now, so hold on. So, what we basically we've been talking so far about the problem of I have too much data. I need to narrow it down so that I can save money, I can save time, I can do things more efficiently. In fact, there is also another value proposition, which is by reducing the amount of data, if you can get rid of the harmful data, the data that basically sets the model off, right? Technically, you could get a better model with less data, right? Now we're starting to look at the opposite side of the problem and the spectrum, which is I don't have that much data. How do I efficiently collect or generate the right data, right? I mean, so, we're pioneering a new technology called, active synthetic data generation. So, and this is something that can be applied for, data collection as well, which is essentially to say look, you have a small data set. right now, like basically like the only option you have is just like keep growing this by, like if you're an autonomous driving company, by driving around the streets of San Francisco until your model gets better from it, right? But now if you knew that the data that truly helps the model is the data that you collect after 5 p.m. but before midnight from highways where you have a high density of traffic, right? If you knew that, you could save yourself a lot of hassle and you could be a lot more strategic about what to collect, right? Or applying this to synthetic data is like you would know what to synthesize, right? I mean, so basically providing this feedback loop, I'm like, look, instead of like collecting a ton of data and then figuring out what the value is, if you know from the get-go where like the type of data that carries the most value, then basically you can also save people a lot of money. And so we've helped companies before like strategically collect the right data so that instead of randomly collecting data for a year, they can get to where they need to be in a couple of weeks or a couple of months.
Wow, that's fantastic. And that's sort of the image that came to mind for me was basically I was like setting up a new iPhone, for example, if it has the Touch ID. And when you're putting the fingerprint in, it'll tell you, I don't even know if it's real or not. Like, I don't know if it's accurate, but it'll tell you which parts of your finger it has a reading from, which parts it doesn't. And that really helps make sure that you're not giving only redundant information and that you're sort of giving it all the information that it needs. And so I see a lot of value in being very aware of like the gaps in the data rather than spending a lot of time on stuff that isn't so valuable.
Actually one thing I would add there, which is like a really interesting space for me, right? I mean, so it's like, I see the market and basically I'm going to say like, like the fear of a recession is going to help us get there faster. But so what we've been doing so far is what we call machine learning, right? I mean, and so machine learning is like, here is the data, you feed this into a model, you expect the model to make sense of it, right? I mean, so basically that's what was, made us feel like, like it's almost like you show books to students without curating, right? I mean, basically you're just gonna, the belief obviously is going to be like, how can I make the student better by buying more books and showing them more books, right? I think we need to enter, and this is already happening, what we can call like the machine teaching phase, right? Which is actively acting on the data, because this is what data-centric AI is all about, right? I mean, to basically like take actions so that the model can get there faster by being a teacher to the model instead of just like passively feeding data into the model, right? And so that goes by feeding better data, curating the data, and actually also goes into like strategically boosting the model by acting on the activation function that you should be like looking at or whatnot. So it's like things that we don't do yet. I don't know if we'll ever do this, but like I really hope to see this shift on the market in the next couple of years.
Wow, I love it. Machine teaching, the next era of machine learning. I love it. So Jennifer, do you have any advice that you want to share with anybody listening to the podcast today?
My word of advice for young professionals and like whoever's interested in machine learning is really like, look, it doesn't matter like how wonderful your model is or whatever. I think we're achieved like a lot in machine learning over the last few years, but if we cannot convince like the organizations we work for that they can do these things efficiently for like an enriched ROI, eventually they're going to stop funding us, right? I mean, and so I think it's really important for people to realize like, look, we need to learn to be more efficient, we need to be more cost efficient, be aware of the impact of what we build for our organization. That goes through cost. It goes also through ethics. It goes through a lot of other things. So, I mean, this is another, kind of shift I hope to see in the market among young professionals, to be like more in touch with, what they're building, what they're building is impacting the world, the society, and the companies that they work for.
Love it. Love it. Well, thank you so much, Jennifer. Really appreciate you taking the time, and best of luck with all of your endeavors moving forward.
Thank you so much. It was a pleasure.